up newspaper cellulose, as opposed to a 30 kilo, 20 litre, two 10-litre buckets of sand, basically, for almost $10. So it's a lot cheaper to go the cellulose. So if we can get it to work this way on the cellulose, it's a lot cheaper. And of course, it's all carbon. Of course, so basically carbohydrate moieties all joined together. Glucose, galactose, all these sort of basic sugar units joined together to form your cellulose. And well, it's had the lignin taken out because it's newspaper cellulose. So anyway, let's go back to where we're going. Does it burn up more specs when it's on spot colouring compared to that? Anyway, I've got some left in the bucket, and it's still got formula, but as it goes through, I'll keep pouring on the formula, and it'll basically come up to the surface of the bucket. It'll be brimming, and we'll see what happens, whether it will shrink down over time, or will it stay permanently the same height, which will be another bonus. Maybe it's self-adjusting. In other words, as it tries to shrink down, it just takes on more water. And stays the same level. But anyway, I just thought I'd show you that and say I'm pushing ahead. I've basically found 2 lines that are working, and I'm working on them to improve them. And the one over there says it looks like it's going to get better and better over time. It's just like self-propelling itself. So we just need more rain. And it said we've had such a wonky year. All the plants in the neighbourhood have gone wonky. We've got eucalypts flowering now. 4 or 5 months out of time. Just crazy. So anyway, I've done a lot of work, got a lot of data coming back, and as I said, basically I've got 2 lines now that are working. I've learned a lot more, and pushing ahead. And I don't know if you can see this, but I've got this spath that's barely keeping itself alive. This one here, I don't know if you can just see that. It's barely alive, but it's slowly putting out the leaves. Got a little bit of moss there. You can see that. And hopefully, eventually, that will all get covered with moss like we had last year when we first started off. Didn't quite know what we were doing last year, but now I've got 2 lines that I'm developing now. And I think we're going to see a few surprises if we can just get the rain to flush through the pots and get things going, and then things will start to take on like an exponential, speed, and we start getting moss and hopefully liverworts developing on the surface of the soil, and maybe some seed germination. As I said, I put some Planchonii in there, easiest germinator, and I'll be very happy when I see Planchonii germinating on the surface of the pot. I'll know we're home and hose, because as I said, that's our easiest germinator. If I can get Planchonii to grow, I know I can grow any other CP basically. And it would be interesting to see how quickly the Planchonii will grow, and can we get an adult plant in a season? I mean, if we can do that, we basically saved ourselves 3 to 4 seasons, because normally it's between the 3rd and the 4th season it'll put up its cup traps. But Donny could do it in 2 seasons. In the 2nd season he could get substantial cup traps. Something that's about 3 inches high. I've got video up online. I showed it to Joel. I sent him the link to the video. I'll probably put the link to the same video and the timestamp for when the Planchonii shows up. It's in its 2nd season. You can actually see it. I'll put both links. I'll put the 1st season growth and I'll put the 2nd season growth. And I think you'll like it. It's amazing what he did in 2 seasons there. And of course, he grew the pink flowered Potada foliosa hookerii things from Mount Bold. He grew them up to flowering size in a single season in a little greenhouse thing he made. You've seen those, probably seen those as well. So he did a lot of work. Like I said, it was the hardest working seed here in our society. I think. You know, yeah. I mean, I've had to be catching up with all the work he did, I think, with my own work over the years. You know, I think he did as much work in those first few years as I've done in the last 30, I think. So, you know, he was probably doing about 10 times as much 10 times as much work. So anyway, we'll see how we go, but that's basically what I've got, is a few insights, a well drain, you know, a chemically stable, well drain, so it's chemically stable once it gets to a chemically stable state, well drained anaerobic soil with little or no chalkiness. So it's this thing about chalkiness between being muddy, clay, mucky and not chalky. It's a fine line, I think, but I think we're going to get there. But it's nearly getting there, nearly drained through, and then I can put the next half in, and I reckon it's going to brim. This one's going to brim, and it'll be a perfect brim, and then it'll get rain through, and we'll see what happens when it gets rain through, how the mucky cellulose actually responds. So, but as I said, if I can get something growing on the surface, can you imagine what the roots are going to do? I want to see those big, fat, capensis-like roots we used to see in the 70s. Those big, thick, sort of felt-tip pens, or, you know, the slightly thicker ones. You know, the texture thing, you know, about, you know, you had the standard pencil about that big, and then you had these sort of texture felt-tip things that were slightly thicker. Yeah, we used to have roots up that side, slightly toast, different range of colours, sort of orangey red to red, sometimes with pinky magenta tips as well, and things like that. So, yeah, very interesting. Of course, if you want to know the true health of the capensis, it should do that double fiddlehead thing, and also the stipples should be at least translucent white, or best yet, or still, a magenta red. If you can get the stipples to be a magenta red, and you've got this double figurehead, it's probably got the best health of the capensis, and then you should be getting some good root growth too. And of course, some of these plants, the roots can go really long, like a banana. And banana is different to a capensis. It can't stand being dried out, whereas capensis, you can, you know, bring it back from a dried out, as Donny's shown me a number of times in the past. You can bring it back from a dried out lump of peat sort of thing, and it will survive. Whereas banana, you know, a day or so without being in damp soil, that's it, you know, and the roots had gone basically. Whether that's because we're not knowing something, I don't know, but that seems to be the general fare, is that, you know, the banana roots have to be damp all the time. So if we can have a bucket of nice damp newspaper-cellulose, you know, a mucky newspaper-cellulose, maybe we can get some really decent banana roots and get some really massive plants. Yeah, anyway, we'll see how we go. But I just thought I'd give you a bit of an update, give you some motivation. It's all go here, slowly whittling our way down to the tip of the triangle. So we've got two lines, probably either side of the triangle, coming down to some miraculous point, I don't know, miraculous bit of understanding. Yeah, and then once we get there, we'll probably work backwards from it, and you know, correct all our little mistakes over the years and sort everything out, and yeah, have a general workup and some new set of rules, you know. As I said, the chemically stable, well-drained, anaerobic soil with little or no chalkiness is basically my overall descriptor, I think. But we'll see how we're going. But using our, and go from our controlled plant, basically, we've picked over the years from all the ones we sorted through. You know, the other one is a dandelion, of course, but this one's a good one, though. As you can see, it's starting to perform. It's starting to do that elongation business. And oh yes, I didn't show you, did I? No, I should have shown you this. This is what I'm saying.